we get to hear stories and experiences of incredible women in science and technology. Not only will you get insights into some fascinating innovations, but you may also even relate to their stories, especially if you're a little bit unconventional or non-conforming yourself. As with all science and technology, what these women do for a living has a real impact on all of our lives, and we don't often realise it. But here on Innervation, I'm also giving women a platform for them to be heard and for us to be inspired and uplifted by what they've learned along their life's journeys, both personally and professionally. This week, I talked to manufacturing engineer Bethany Cousins.
My name is Bethany Cousins. I'm a manufacturing engineer at the Advanced Manufacturing and Research Centre with Sheffield University. So that involves I work on lots of research projects where we're trying to improve processes, work with our companies close by to try and improve things for them.
The whole idea of like smart manufacturing and advanced manufacturing can sometimes go over my head because I see manufacturing as something that's like big machines and it's quite a dirty business, and you know it's really sort of like labor intensive. So how is it going in a smart or advanced direction?
So more and more we're moving towards the digital aspects of manufacturing. So we have a big shop floor here at the AMRC where we do have like some of the big machine tools, and there are aspects of that can get like a little bit dirty or a little bit more involved. But more and more we're trying to push towards that digital aspect, making sure everything's proved out digitally before we hit the machine so we can be more sustainable. We're not wasting as much material. We know how things are going to run on a computer screen before they actually hit the machine. And we can do a lot of the research tasks now with the background of knowledge that we've managed to accumulate so that we can find out a lot of these things without actually hitting the machine. And then when we do get on machine, it all runs much smoother. Like I say, it's more sustainable. We're not going through as much material and we can learn things much quicker.
So is that the aim then, to just be more sustainable and more efficient with what you're making, or are there other aspects to advanced manufacturing that most of us wouldn't know about?
So I'd say there are definitely like other aspects. We've got sustainability is one of the big themes that runs through our company. Everything that we do, we try and improve things to make them more sustainable. A lot of things, as things are adapting, are having to be more sustainable as well. So if, say, we're looking at a lightweighting project for something that's going to go in an aircraft, fundamentally that's going to make it more sustainable. But yeah, there's definitely like other themes that we're following that'll improve things as well.
So what would those other themes be?
It's new technologies that we're trying to understand and develop, trying to bring as much manufacturing back to the UK as we can. So that's really important. We want to be able to do things ourselves, and these new technologies are going to make that so much more accessible. You can't compete with like prices of how cheap they can be made in China, but if we can make them more in a smarter way, then we can compete. But if we're just doing things the old-fashioned way that things have always been made, there isn't any competition.
Right. Yeah. Because I mean, there's something that's really fascinated me that I've come across is that, we really rely on electronic devices these days, whether that's our cars, our washing machines, our phones, like they all have electronics in them that have to be manufactured. And a lot of that manufacturing happens elsewhere, like not in the UK. So are there basic things that we have to change here in the UK to become more self-sufficient? Because, without circuit boards, we can't have electronic devices, like our cars wouldn't drive. So like, what do we need to change here in the UK to be more self-sufficient?
Yeah, I think a lot of it is taking that step back, it's a difficult one for companies to do, because obviously you're not continuously pushing forward and manufacturing more and more components. You have to almost stop where you are, rethink things, look at how they're made, try and do it in a different way. But if we can take that step back, come back to like the research environments and develop these new techniques, and then we can implement those, then we can produce these things in the UK. We still have some of the best like manufacturing facilities in the world in the UK, so we can do it. And I think a lot of the time it is just that being able to have that pause and take a step back that is really important.
What is manufacturing?
Manufacturing is the way that we would make anything. So everything that we use on a day-to-day basis, anything that's not natural, has had to be manufactured somehow. So everything has been engineered in some way. So it's just that process of going from a raw material all the way through to that finished product that needs to be manufactured on so many different levels and different scales. So we can get to those devices or components that we use on a day-to-day basis, or that are used in different environments.
So what would be examples of older, more traditional manufacturing methods?
You could say that older methods would be much more manual. We've got ways now where we can do things that are much more automated, and it doesn't have to take away from moving towards a robot instead of a human. We still need that human presence, and you still need them to interact. So it's not taking jobs away from people, it's developing those people and giving them a new, more involved role. And like I said, with the digital aspects of manufacturing now, we're trying to do everything digitally before we do it physically, just so that we can get that better understanding. And we know we can trust better that something's going to work before we actually make something, trial it, and then have to go back to square one.
Right. So I guess traditional old manufacturing methods would have been like, tools, like CNC machines and lathes, and like all these machines that basically carve materials or melt them down, and they're put into molds, and just building things from metals and woods and plastic, and so all of those tools are part of manufacturing, right?
Yeah, and they are still a massive part of manufacturing. We still need to use those to get to where we are, but the technology that we can put into these machines now, and the knowledge behind it all, is just so much more advanced. We've got a lot of teams working at the AMRC that are trying to prove out new processes. So I was quite heavily involved in the gears team at the AMRC, and one new process that we're really looking to develop and push forward is called power skiving. And that's a method of making gears on a conventional machine tool. So that's a machine tool that isn't usually made specifically to make gears. It can also do milling and turning and different aspects. So if we can then produce a gear on that machine as well, where we can reduce the footprint on the shop floor, we don't need to buy a specific machine tool that can be really expensive just to produce a gear, and that's all it can do. You can then potentially get better tolerances because everything's machined in the same setup. So it's just trying to push these machines as far as we can to get the most out of them.
Oh, right. Okay. So I think sometimes when people think of smart manufacturing, they immediately just jump to 3D printers. Like, is that kind of like a really basic way of seeing manufacturing as being advanced? Like, have we moved beyond that?
So 3D printers is like a massive area of manufacturing. And I think when people jump to that conclusion, because it is something that's so new, it's so innovative. Like previously, whenever you manufacture something, you're taking material away from it, whereas this is building it up from nothing and you're adding that material on. So it's completely flipping the process on its head. So I think that's why everyone goes to that straight away as their initial thought. And it is something it's impressive. It can do so much things, and they're developing and improving on that all the time. And it can be used for so much more than it could previously. And it will be, it's a more sustainable process in a lot of ways, that we're not wasting that material that we're just getting rid of. And it could be a really good technology to employ in a lot of situations.
Yeah, I've read that we might be able to 3D print houses. Is that really true?
I'm not sure about a house. I'm sure in the future that we'll be able to, definitely bits of houses. I did see one video, and I suppose you could call it like a 3D printer, and there was a robot arm going around and putting the cement down. So in a way, that's 3D printing, just on a massive scale. So it is possible, and it can be used in so many different ways. It's just exploring those ways and having the mindset to say, actually, we could do this in a different way, as opposed to this is how it's always been done.
Are there any other aspects of manufacturing where our thinking is being turned on its head, that you haven't mentioned already?
I think the stage where we're at with manufacturing at the moment, I think is very much, we're in that phase of, we're trying to flip everything on its head. We're trying to, as an industry, we've almost realised that we need to make these next steps and to progress even further and get these new inventions of things, that we're going to have to flip it on its head and look at things completely differently to how they have been done before, and try and forget all of those past experiences. And I think that's where it's really important to get young people involved, because they haven't had that. They've not been like tarnished by what's been done previously. They've got their own ideas. They're already outside that box. So now I started as an apprentice, and I'd never seen any of it before. So sometimes you'll come into things and you'll have ideas, and you might be told, like, oh, that's not how it's done, but keep pushing those ideas, because it could be how it's done in the future.
I mean, that's so awesome to kind of see you essentially carving out the future of manufacturing by having chosen to do an apprenticeship, and being at an organization that is all about advanced manufacturing. And we'll definitely come back to that. But on the subject of young people, I'm sure there are many people that are like fascinated by 3D printers, and it's really amazing to think that it's such an important part of manufacturing, because I think we've got to a point where a lot of people think 3D printers are like the printers we have on our desks, and we could like make little gimmicky things like jewelry or, you know, just fun things with a 3D printer at home. But actually, it's really cool to think that 3D printers are like scaled up for industries. But for any young people who are quite curious about manufacturing as a possible career choice for them, what would you advise in terms of the skills they need to build up in order to have a prosperous career in manufacturing?
Yes, that's really interesting. So it can be a complete range of things that you can go into. Manufacturing and engineering as a subject is so broad, and there's so many different areas. I honestly believe that there'd be somewhere in there that everyone will be interested in, someone could specialize in, and that they could really excel in. So I don't think really you have to focus too much on anything. Like you say, if you're really interested in the 3D printers side of things, then that's great. Keep that interest and try and develop that. But as I say, I started my career as a level 3 apprentice. So that's just after your GCSEs. And all I needed to get onto that apprenticeship was like I can't remember off the top of my head. I think it was maths, English, and a science and just at a C level. Because you're starting as an apprentice, you can learn everything as you're going through. You don't need to have too much specialization before that. That you've got that opportunity as an apprentice to learn and develop the skills you need and apply them as you're doing it so that you can really excel in your career.
Why did you choose to go into manufacturing? Because I hate to say this, it makes me cringe, but it's not a typical choice for a woman.
No, it's not. Like traditionally it hasn't been, and I'm still definitely in the minority. But for me, as I say, I've really enjoyed my career so far. It's been like really interesting, and I'm getting to do new things and develop new things every day. And there isn't anything that puts me off my job. It's every day it's more interesting. So for me, I did enjoy like the sort of like maths and physics subjects at school. But I'm also a quite hands-on person. So the apprenticeship really suited me because I could apply that like maths and physics knowledge I was getting in the classroom to engineering. So something that is tangible, that you can see and that you can see improving, and you can really make a difference with it. So that's why it suited me. But as you say, it was almost a step outside the box to make that step if that's a career choice for me, because it's not always been sold as that, and not everyone will see it as that. But it is something it needs improving, and it is improving every day. But yes, engineering is definitely a place for everyone, and it's such a broad topic that, like I say, anyone could find it interesting somewhere.
So what gave you the courage to say, yeah, I'll go into a career like manufacturing that probably is male dominated and, you know, has that sort of, I don't know, like very industrial kind of perception?
Yeah, I do think it helps with me. I've got like a family background in engineering, so I'd had a little insight. So I'd seen what it's like. I'd seen what it's like firsthand instead of just what you hear and what people say about it. So that definitely helped with me. And it's just having that confidence and the openness to see that everything is an option for you, and really focusing on what would suit you, not what your friends are doing and what they think is interesting. It's finding something for you because it's your career. There's no such thing as a work-life balance when you're at work 5 days a week and at home too. So you need to enjoy what you're doing and make sure you find it interesting.
Did you get a degree out of it?
Yes, yeah. So I started at level 3. I did an apprenticeship then. I stepped away from like the apprenticeship side of things, and I did a HNC and a HND. And then most recently, I went back to an apprenticeship to do the degree. So I graduated a couple of weeks ago from the University of Sheffield with a bachelor's, but was getting paid and continuing with my career at the same time the whole way through. So I've been progressing both academically and on a career side as like simultaneously. So it's been like a fast track for me with being able to do them both together.
Well, congratulations on graduating. That's awesome. Massive milestone reached. What have been the highlights or the aspects of your apprenticeship and your experience in manufacturing that you have loved the most?
So one of the positives of an apprenticeship is that you're with this pool of people that are all like-minded. They're all doing an apprenticeship, but it's not all in your exact area of manufacturing. So I've like each class that I've been in, you've been in with say 20 people, all working for a different company, all with different experiences, different specializations. And that's a network of people that I still carry through my career now. And they're people I can rely on or ask for advice from. And I can always access that group of people. And just being able to do that academic learning at the same time as continuing in like your career and being able to apply that academic learning straight away in the work environment. I've remembered so much more than I definitely would have done if I was just sat in a classroom for a few years and then had to go and apply it. And you've been able to improve it and see exactly what you're learning, why you're learning that and how it's helping. So I think that's just been like invaluable. What
do you actually do on a sort of like daily or weekly basis? Like, what does a job in manufacturing look like?
my job at the AMRC is very varied. So I think that's one of the things I do like about it so much. We get research projects come in where you'll have a problem or something that needs improving. And initially you'll look at that problem. You'll have to decide how we're going to tackle it, how we're going to improve that problem. So initially you're more of like in the planning stages, and that innovative side of things has to come out. Then you'll move on to like some computer aided machining. So you'll be doing all of that, those digital aspects, trying to prove processes out, investigate how things can be done. So that's all very like laptop based. But then also you'll probably take that onto a machine based trial. So then you're getting more hands on again. You're seeing things be made physically. You're like collecting loads of data throughout all of this, which then you'll analyze, put all together in like a report style format and feed all of this back to the customer. So there's lots of customer engagement and just research engagement, trying to engage with as many people as possible to get all of these ideas in and see how we can improve. So it is really varied, and no project is the same. It's always different, whatever comes in. So it's keeps it interesting, definitely.
Is there anything out there in our everyday lives that you've worked on that we'll recognise?
So potentially, like the AMRC is in very close partnership to Boeing. So we're based in Sheffield, and Boeing Sheffield just opened across the road. So we've got a really close relationship with them. We do lots of research projects for them and working in collaboration with them. So while they're continuing their production, they can give us a problem that we've got this that needs improving slightly, but we haven't got the time to stop production because we still need to carry on. So we can go away and look at that for them. So there'll be definitely bits of that you might have seen in real world.
You know, your work just sounds so like academic. You know, you're researching, you're testing, you're experimenting, you're writing out your results. I personally would love to have that kind of job. But yet, with all of that research, it's so hands-on, like you're really in the thick of it. Like, are you aware that what you're doing is really like a total harmonizing of academia and kind of the practical side of things?
I think from like an inside point of view, it's difficult to always see that. But you can just see from like our workforce that you don't need to have had an academic background, or you don't need to have had that more hands-on experience to excel here. So just looking around like the office that's sort of around me now, you've got people that have done degrees, they've got masters, they've got PhDs, and they're sat next to someone that's got a level 3 apprenticeship, and everyone's working together, and it takes that collaboration to really excel. Yeah,
it really is such a mixture. And I mean, do you feel like you want to get sort of like the PhD and all of those kind of accolades, I guess? Does that interest you?
To an extent, definitely. I think it does, but I don't feel I need them. I feel like I'm still able to progress. I've done well to get where I am and to get to the position I am at work. And I think my apprenticeship background has been the most valuable bit of what I've done. So that combination of the two, and getting that hands-on experience and the academic knowledge at the same time, has been the bit of my career and the biggest choice I've made that has really, really helped. So I think I'd definitely push people or encourage them anyway that was the right decision for me. You don't have to just go down one route or the other. It's that collaboration of the skills that really is making the difference.
Yeah, I mean, I must say you really are in the grey overlap area of the Venn diagram. And, hands down, every apprenticeship or apprentice that I've interviewed, I just wish I had chosen an apprenticeship when I was thinking about a career in engineering, because you just get something so special that you don't get at university. But I also, time and time again, hear about the importance of collaboration and how it does require this mixture of perspectives and experience. And I must say, sort of listening to your experiences being in advanced manufacturing, like, it just sounds so exciting and fresh, and there's so much potential in the future for where you are to just grow and keep evolving. What do you think are the challenges that you face doing what you do? Because it just sounds so positive all round at the moment. Like, is there anything that you struggle with a little bit?
Yeah, so I'd say one of the big challenges is it's keeping up with this technology. So things are advancing so quickly all of the time. It's being able to get that background knowledge that can then get employed in industry. And then the big challenge of getting industry to convert over to it, because they've been doing things their way for so many years and it works. Why would they step away from that? So that's a big challenge, and something that we're really working on is to get that next step and get it actually in industry and being used. But you're always learning. You've got to be keen to keep learning and keep on researching and finding out all these new technologies that can be employed. Because, like I say, it's just moving at such a fast pace. There's always something new to learn.
Do you code?
In ways. So there's so all the CNC machines, they need coding. So you put in, you write programs, but a lot of the time now that's done through like the computer aided manufacture that we're doing, the CAM processes. So that technology's come so far now that you can like draw tool paths that you want to follow on the machine, and then you can, it's called posting that program out, and that'll post into the code that you need on the machine to then allow that to run. And you can run that through simulations first on your laptop before you hit the machine tool, and that'll show you exactly what it's going to do before you do it on machine. So it's safe, and it's doing exactly what you want it to. But there is so many different areas of like coding that I am definitely not an expert in, but that's what I mean with like so many areas that you can specialize them and get interest in, and there really is something for everyone.
So where do you hope to see your career progress? Like, what are the next steps for you in the next several years?
So just keep learning as much as I can, gain as much like knowledge from all these people that I'm like lucky to be surrounded with and work with every day. Try and pick up as much of that as possible. So just keep striving in my career and see where the next steps take me, see what opportunities come my way and where they'll be suited. I want to always be interested in the work I do and enjoy it. So I want to keep moving and developing to make sure that that is the case.
You sound like you're not driven by money or power, or it sounds like you have a real genuine interest in making a difference in manufacturing. Is that a fair assessment?
To an extent. Obviously we'd all like more money, but I think if you can keep progressing, like, and keep developing your skills and keep that interest, the other side of things will come with it. So if I can keep learning new things and developing and being a better engineer, then those opportunities will come with more money and all the extra things. But as long as I'm interested in enjoying it, that should hopefully come naturally.
So the stereotype of like jobs in manufacturing being sort of like being on a shop floor, very labor intensive, overalls, lifting heavy machinery or parts. Is that a bit mythical, or is it actually really like that?
Not at all. Obviously, there are aspects that will still need to be like that, but it's not just that at all. So there's all of these different ways that we're looking at manufacturing now, and it's not just labour intensive, really manual. There'll be people here at the AMRC that they never touch a machine, but they're still progressing and making new ideas and innovative like breakthroughs in technology. So it's just picking what area suits you, but there will, like I say, there will be areas where there will have to be some manual intervention and things, but it's very limited and it's getting less and less limited. And even with the technology you've got now to help with that, so like that, you've just got like an overhead crane and things that are just accessible so easily, so you don't have to do that yourself. And it's just there is aspects of it, but there's just so much more as well.
So for anyone sort of who has heard you and they're thinking, wow, that her career sounds really interesting and kind of different, what advice would you have for anyone whose curiosity has been piqued? What kind of person should be going into an industry like yours?
So I think that's, again, there's such a broad group of people that could go into this industry. And I do think that there's a place for everyone. And if it has like spiked your interest, do that research, look into all the different bits of engineering. Even if it's one little bit I've said, have a look into that, and you'll find that that's an absolute like massive information there and different areas you could go into there. So I just think, have a look, see what is out there, see what the options are. You don't have to be too committal at first. Like I say, if you went through the apprenticeship route, you've got that time to experience different things hands-on as well. So then you can progress and say, oh, well, I wasn't that interested in that bit that I did, but what we're doing this month is really interesting. And then you can direct your career down that route. It's just, there really is a place, I think, for everyone to find something interesting.
Well, it's just been incredible hearing about your story and learning a bit more about the job that you're doing. It sounds like you're in an industry that is really transforming and updating, and it's so exciting. And I'm kind of really chuffed for you that you've chosen a career where you can almost create your own niche within the industry, and kind of you can drive the direction that your career goes in. So thank you so much for sharing all of that with us.
No, thank you very much for having me. It's been great to talk about and share these experiences. And I really do hope that more people do start to consider that career in engineering. And especially, as you said earlier, as a female, like, it's been a great career choice for me. So I really would advise that people at least consider it as an option.